This is a video for the final review in my Calculus 1 class. The directions say to evaluate each integral. Let's take a look at problem 5. Suppose we have the integral from 0 to 1 of y times y squared plus 1 raised to the 5th dy. So what I'm going to do is let u equal y squared plus 1. Du is 2y dy. Y dy is 1/2 du. So now, what we need to do is change the limits from y to u limits, right? And I'm going to plug in up here. So when y is 0, u equals 1. When y is 1, u equals 2. And so this is equal to 1/2 the integral from 1 to 2 of u to the 5th du. Okay? So this is equal to 1/2 times 1/6 u to the 6th evaluated from 1 to 2. Now, 2 times 6 is 12. So I'm going to pull a 1/12 out in front. And then I'm going to get 2 to the 6th minus 1 to the 6th. 2 to the 6th is 64. So this is 1/12 times 64 minus 1. But this is equal to 63 over 12. Now, if I divide the numerator and denominator by 3, right, I'm going to get 21 divided by 4. And that's how we do problem number 5. Let's take a look at problem 6. Suppose we have the integral from 0 to 2 of y squared times the square root of 1 plus y cubed dy. So I'm going to let u equal 1 plus y cubed. Du is 3y squared dy. So y squared dy is 1/3 du. All right, now, when y is 0, u equals 1. I'm plugging in this line here. When y equals 2, u equals 9. And so this is 1/3 the integral from 1 to 9 of square root of u du, which is really nice to integrate, right? So this is 1/3 times 2/3 u to the 3/2, right? So if you want, we can put the 2/3 u to the 3/2 in parentheses. And I'm going to draw this vertical line here. And what it says is to evaluate from 1 to 9. So I'm going to put 1 to 9. Now, 1/3 times 2/3 is 2/9. So I have a 2/9 out in front. Then I'm going to get 9 to the 3/2 minus 1 to the 3/2 inside the parentheses. Now, let's come over here for a sec. 9 to the 3/2 is another way to say it is square root of 9 cubed. But that's 27 because square root of 9 is 3. So this is 2/9 times 27 minus 1. So the correct answer here is 52/9. And that's how we do problem 6. Let's take a look at problem 7. Suppose we have the integral of x over x squared plus 1 dx. Now, this is an indefinite integral, so we're looking for a family of functions. So I'm going to let u equal x squared plus 1. My du is 2x dx. X dx is 1/2 du. And so this is 1/2 the integral of 1 over u du, which is 1/2 natural log of the absolute value of u plus some constant c. But u is x squared plus 1, which is always positive, right? So we can write 1/2 natural log of x squared plus 1 plus c. That's number 7. Let's take a look at 8. On 8, we have the integral of 1 over x squared plus 1 dx. It's perfectly fine if we write the answer directly. This one happens to be arctangent x plus c. That's it. Number 9. Suppose we have the integral of sine of natural log of x divided by x dx. So I'm going to show you something, and maybe this will be helpful, but we'll see. I can write this as sine of natural log of x, and I'm going to take that quantity times 1 over x dx. Now, the inside function is the natural log of x. So that's a really nice choice of u. But du is 1 over x dx. And so this is the integral of sine of u du. If you guys hear YouTube in the background, I apologize in advance. That's my child. Now, this is equal to negative cosine of u plus c. But u is natural log of x. So this can be written as negative cosine of natural log of x plus c. And that's how we do 9. Let's take a look at 10. On 10, we have the integral of x over the square root of 1 minus x to the 4th dx. But this can be written as the integral of x over the square root of 1 minus x squared raised to the 2nd dx. Now, I'm going to let u equal x squared. Du is 2x dx. So if I solve for x dx, I get 1/2 du. So therefore, the integral of x over the square root of 1 minus x squared squared dx is 1/2 the integral of 1 over the square root of 1 minus u squared du. So this is 1/2 arc sine of u plus c. But u is equal to x squared. So this is 1/2 arc sine of x squared plus some constant c. And that's how we do problem number 10. I want to take a look at 11. So on problem 11, we have the integral of x plus 2 divided by the square root of x squared plus 4x dx. So my u is what's inside the integral. So u is x squared plus 4x. My du is 2x plus 4 dx. But can you see that I can factor out the 2? And when I do, I get du is 2 times x plus 2 dx. But notice I'm going to solve for x plus 2 dx. So x plus 2 dx is 1/2 du. And so this is 1/2 the integral of 1 over the square root of u du, which is 1/2 of 2 square root of u plus c. But remember, u is x squared plus 4x. And so this is the square root of x squared plus 4x plus c. And I want to take a look at 12 and 13 for this video. So on 12, we get the integral of cosine cubed x dx. So I want you to notice the odd power, okay? And so what I'm going to do is I'm going to save a cosine. So in other words, I'm going to write cosine cubed x as cosine x times cosine squared x dx. So the reason why I want to do that is because I know an identity to rewrite cosine squared x in terms of sine squared x. Now, why would I do that? I just know that the derivative of sine of x is cosine of x, and that will allow me my u substitution. So in other words, I'm going to write this as the integral of cosine x times 1 minus sine squared x dx. And then notice that the derivative of sine of x is cosine of x. So I'm going to let u equal sine of x. Du is cosine x dx. So this part and this part get replaced with du. And so it's a nice integral. We have the integral of 1 minus u squared du, which is u minus 1/3 u cubed plus c. This is much easier than this line, in my opinion. But remember that u is equal to sine of x. So I'm going to replace u with sine of x. And so we get sine of x minus 1/3 sine cubed x plus c. And we did it. That was number 12. Let's take a look at 13. Suppose I have the integral of sine cubed x dx. Now, in this case, just like in 12, It's a similar idea. I'm going to this time save a sine of x because the power is odd. So I'm going to write this as the integral of sine of x times sine squared x dx. But this is the integral of sine x times. Now, sine squared x is 1 minus cosine squared x. And I'm going to integrate that with respect to x. And I just happen to know that the derivative of cosine x is negative sine x. So it's just offset by a negative, which is totally fine. So I'm going to let u equal cosine x. My du is negative sine x dx. So sine x dx is negative du. So this is negative the integral of, and then it's 1 minus u squared du. Which is, now, if you want, before we actually continue, I can distribute that negative in and write this as the integral of u squared minus 1 du. So you distribute the negative, you just change the sign of each of the terms. So this is 1/3 u cubed minus u plus c. But what is u? We go back. U is cosine x. So the correct answer here is 1/3 cosine cubed x minus cosine x plus c. And that'll conclude this video for the final review. And we evaluated an integral and did problems 5 through 13 off the review. Okay, thank you.